So let's start. So welcome to the next Vacuum deal. Today we are going to dedicate the session to crypto. But we are not going to talk about if the Bitcoin will go up or will go down, whatever. We are going to talk mainly about the technical concerns, architecture, and future of the development, which is going to be interesting as well. And we have three amazing speakers. The first is David. He's going to talk, he will introduce himself during the talk, but he's going to talk about the underlying technology, which is the blockchain of Bitcoin. And David is CTO of Fumbe.
CIO.
CIO, okay. Chief Investment Officer, okay. Cool. And the second speaker is Martin Tolko, who is the developer and blockchain smart contract developer at Vacuum. And the third speaker is Petr Menčík, he is Polkadot Trust, owner, cool. And okay, I don't want to talk too much, I will hand over to David.
Dáš mi slidy? Hello everyone. So, cool. To dole napravo. Cool. So today I want to talk about. When I was thinking like how to, how to create this presentation, I wasn't sure because like I assumed that probably everyone knows Bitcoin here. Who is developer? Can you raise your hand? Oh, it's everyone. Cool. So who knows? Who is familiar with the code base of Bitcoin to some extent? Not so much. Okay. So. That's good because at least it won't be so boring. Hopefully, yeah. So I kind of trying to do a little bit experiment here. Like usually when I talk about this topic, it's much longer. It's most of it is taken from my first or maybe third lecture in the university course on cryptocurrencies that I do at University of Technology in Bratislava. But so I decided to take part of it here and mix it with a little bit of some news from the Lightning Network and the Taro protocol. I'm not sure if you have heard of it. It will be just very brief. It's very new. It was released just like a few weeks ago. So I'm not so much familiar with that myself. But I believe it's very interesting. And I will a little bit sneak one slide from the ancestor, like technological and ideological ancestors of Bitcoin that you may not be familiar. So let's start with that. Yeah. So, okay, now first question, so who here could say some projects that were before Bitcoin? Like we can consider to be, the predecessors of Bitcoin. Anyone, some guesses? Hashcash? No. Yeah, good one. Some other guesses maybe? It's low, okay. So Hashcash was one of them, but not so many people know that actually some of the first digital currencies were emerged in 1990. So kind of like 20 years before Bitcoin. And the very first one was DigiCash. It was a very hot startup in Amsterdam, founded by David Chaum, which is one of the most famous cryptographers in the crypto space. He's still active. He was awarded like a Turing award a couple of years ago, and he's really a great engineer and mathematician, but a terrible manager. And that's why DigiCash failed and went into bankrupt after David Chaum refused to get acquired by Bill Gates in 1994, and the concept was to be incorporated into Windows 95, but it didn't happen eventually. So the company ran out of money and shut down. After that, a couple of other projects emerged that were trying to create a more decentralized version of digital money. And some of them are really important, like Hashcash. That's first time, or actually not really first time, kind of second time, when a proof of work concept was used. So some people think that Bitcoin was the first concept where proof of work concept was used, but it's really not true. Very first time it was like in 1991 in another project, but in relation to the digital money, it was first time using the hash cache, which was very nice, but it didn't go. It was just a paper, basically, just an idea. It didn't went into production or even a prototype stage, which was the case also with some other projects like B-Money or BitGold or Karma. The only project that went into production or kind of had some prototype was RPOW, which is a shortcut for reusable proof of work, which was created by Hal Finney. Does anyone know the name, Hal Finney? It was the first person who received transaction from Satoshi a few years later when Bitcoin was invented. So the problem with RPOW was that it was super centralized. It was relying on a single server, even though it was like functional, and it was even used a bunch of enthusiasts at the time. It was completely centralized, so of course it couldn't work as a decentralized money. And then Bitcoin happened, and from that point, probably most of you know the history. Who doesn't know can read this book. I will tell you about it later. So Bitcoin happened, and now I think it's time to review a little bit the basic concept of behind the Bitcoin protocol itself. So it might get a little bit technical and a little bit boring. I will try to skim through the slides because I have too many slides here, so I don't want to talk about many of them. The presentation is online, so you'll be able to see it and review the sources that you find interesting and get into the concept a little bit deeper. What I do not talk about, and I'm not going to talk about now, is the consensus mechanism, because I assume that's the part of the Bitcoin protocol that most of the people know. Who would say here that knows the consensus mechanism in Bitcoin? More people, more hands. I'm sure you know it more. Okay. So mining we will skip because that takes too much time. But so if we get into the concept of Bitcoin protocol and the first implementation of blockchain, it's one of the most foundational technologies, and like the concept there is blocks, because we have chain of blocks. So blocks are pretty important, and blocks are there to store data. Here you can see briefly what kind of data we do store and what kind of data fields you usually find in Bitcoin blocks. Maybe another question: who in here has some code experience with other cryptocurrencies than Bitcoin? More people, okay. So pretty much most of the other cryptocurrencies were coming from this code source, so you probably will know many of these things. So we have every block contains things like number of transactions, height, like how old or how new is the block, some block reward that is there to mint new coins to incentivize miners to generate the blocks, some timestamps, and things like these crypto things like Merkle root and hashes of the previous blocks, and something like difficulty that tells us a lot about what's the hash rate in the network and how the network should optimize for the difficulty of mining in the next blocks. And some things also is like versioning. When we have things like forks, this thing help to signal how many miners are for which version of the new Bitcoin software. Then we have these data structures within blocks, where you have these Merkle trees. It's probably something that most of you know. Here is a little bit more details about block headers, which also with like how many bytes these things usually have. Again, like same things as we said previously: Merkle roots, timestamps, difficulty, hashes of the previous blocks. It's pretty simple, I assume. And there is, of course, the Genesis block that's a little bit different because, but there is just only one Genesis block in the blockchain, so we don't have to talk about it that much. Yeah, and every transaction, every block contains also this Coinbase transaction, which is a little bit different structure, because that's the Coinbase transaction. Who knows what it is? Raise up your hands. No guesses? So
By the miners?
yes, exactly. It's inserted there by the miners, and it's the transaction that gives them the, the bitcoins. And it's inserted there by the winning miner, the one that guesses the hash and, announces it to the network. And this is the, this is how they get paid actually. Coinbase Transaction. Cool. So here is like a basic structure how transactions, operate. We always, and we will talk about it a little bit more. I hope it will not get too boring, again, too technical, but it's like, very basic thing. We encrypt the UTXOs, and we will talk about UTXOs a little bit later. We basically encrypt the transactions and the bitcoins we are sending to the public key of the receiver, so they can later on, decrypt it and send those bitcoins again. So this is a very basic, diagram how these things work. And of course, if you have any questions, ask me. I'll be happy to answer. I know these slides are super ugly because there's lots of text, but no, I do this at the university, and so it should be kind of heavy with the information. But the main concept here is UTXO. Does anybody know what is UTXO? No, cool. So that's actually how we talk about bitcoins on the level of the Bitcoin protocol. So UTXOs stands for unspent transaction output. Let that sink in. And it's kind of, these indivisible chunks of bitcoins that we are sending in transactions. So every single transaction on the Bitcoin protocol consumes some UTXOs, unspent transaction outputs, and produces some new outputs that can be later on used for another transaction. And so this being said, so what it means to actually receive Bitcoin, it means that your wallet can actually detect that some UTXO on the network has been assigned to your particular public key, and that means that you can spend those Bitcoins with, corresponding signature from the corresponding private key. Cool. Is it clear, or is it super unclear, and you have some questions? Great. I hope you don't lie. Yeah, we talk about the Coinbase transaction. That's a little bit. That's actually, again, only type of transaction that does not consume any UTXO, because it doesn't have to refer to any previous transactions, because bitcoins that are subject of the Coinbase transaction are newly emitted, and that's why then you don't have to refer to any previous transactions, because that's what you do with all the other transactions, that if you want to send Bitcoin, you always have to refer to the previous transactions where you received those Bitcoins. And that's this particular thing about UTXO model that Bitcoin is using, and that you will not find on other cryptocurrencies like Ethereum or any other smart contract platforms. Maybe except of Cardano that uses something a little bit twisted. Yeah. But yeah, I'm not that much into Cardano, so can't talk about it much. So this should perhaps clarify if you have if you're hesitant how the concept works. So in every transaction you have some input that where you consume the UTXO that you previously received, and in the transaction, when you're sending something, you usually, you have some transaction outputs that, as you can see, because the thing about UTXO is that, or about Bitcoin, is that they are really not so well divisible, and that's why we have UTXO. So it means that if you received in the previous transaction 50 Bitcoins, and now you want to send to someone just like 1 Bitcoin, you cannot. You have to send all the 50 Bitcoins. But the way you will do it is that you will spend the whole UTXO from the past transaction, and you create 2 transaction outputs, one of the size of 1 Bitcoin that you want to pay to your friend, and another transaction output of the size of the rest of the Bitcoins that you will send as well, but you will send it to your own address. Does it make sense? Likewise, if you in the past receive a lot of small transactions, like 10 times 1 Bitcoin, and you want to send one transaction of the size of 10 Bitcoin, you have to refer to all the previous small transactions that you received in the past. And that increases actually, the data of the transaction, and that actually also increases, how much you will pay for that particular transaction. So the data heaviness of the transaction is a function of the transaction fees you will pay. Cool, so I think this is also very ugly, but it's important. Every UTXO that you send on the network, you need to you have to kind of lock it. So that's why we have something that we call locking script. Sometimes it's used to call also like witness script or script pub key. Super ugly, I know. But why we have this? It was very simple for Satoshi to create this. We didn't have back then, more advanced systems like we have today. And this UTXO model was kind of simple and deterministic and easy to verify for all the nodes in the network, because they can be kind of really trivially verified. And it also encourages, privacy-preserving behavior. So that's, like probably if you have ever used both Bitcoin and Ether in the last years, you will notice that you usually have 1, 2, 3 Ethereum addresses, whereas if you use Bitcoin for a lot of time, you will probably have hundreds of Bitcoin addresses, because exactly of this, that the way we build wallets in the Bitcoin network is that they always generate new addresses, and that kind of enhances the privacy properties of the network. Okay, I think I'm talking too long, so I will skip a little bit. Again, this is the kind of same thing, just a little bit different form, how it's shown. Again, we have transaction inputs, transaction outputs, this output later on creates input for another transaction, and this is the repeated all the time. This is like super simplified version of it. 1 input, 2 outputs. We have more variations how this can actually work, what kind of transactions we have on the Bitcoin network. So super boring, we don't have to get into it. Transaction fees, as I said, the more transactions you refer in your particular transaction, the more heavy is it in terms of data, and the more fees you will pay. This principle applies usually in other networks as well, usually. Bitcoin script is the programming language that is used in Bitcoin. Some people don't even call it the language. It's kind of a scripting language that it's just a list of instructions, and that are validated by every node in the network. Usually there are 2 kind of scripts that you can have. There are so-called opcodes and some data scripts as well. I will probably not spend too much time on this unless there is someone who is really into it. The Bitcoin script is a language that is coming from another language that was really old, and it's called Forth. And here's the definition of it. If those who would want to play around with it, you can find some applications on this link, and also some ebook that helps you a little bit to understand the language syntax. But it's probably really boring for today, so I'll skip it. This as well. Yeah, the main difference between Bitcoin and all other cryptocurrencies out there now, or like at least the smart contract platform, is that it's not Turing complete when we talk about Bitcoin. Some people say that's a security feature, and some people say that's actually the disadvantage of whole Bitcoin, and that's why many other smart contract platforms were created, because the functionality of the language is kind of limited. And even though in theory you will find a lot of Bitcoin maximalists who will tell you, yeah, we can do NFTs on Bitcoin and we can do anything on Bitcoin, but for some reason it doesn't happen, and the reason is that it's kind of not so handy, and it's much more practical to do it in another way, and that's why we are having so many different smart contract platforms now on the market. So it's stateless verification. That's the key difference between Bitcoin and Ethereum. So in Ethereum and all the other smart contract platforms, you have this kind of account model and statefulness, whereas in Bitcoin all the transactions are stateless, and that's probably very important difference that we should mention. Okay, now we get into this locking and unlocking script. Script signature and script pub key. I'm not sure how much this is interesting for you, but it's very important because that's a part of every transaction. And so always, if you are actually want to send a transaction, what you first need to do is to cryptographically decrypt the transaction and encrypt it to the public key of the receiver. Bam. Yeah, so there are some spending conditions that we always place on the particular bitcoins or UTXOs. And as the Bitcoin ecosystem was growing, we found out more ways and more ways how we can condition different transactions. We created multi-signature transactions. Then maybe some of you have heard of things like Taproot. Who has heard of it? Okay, few people, okay. So that's something that happened actually last year. It's a big protocol upgrade in Bitcoin. It happened actually exactly a year ago, and it allowed some of the innovations on top of the network, but many of them we haven't seen into production yet, but they are coming on the way in the upcoming months and years. So yeah, locking and unlocking scripts, that's a key concept that I will not go into details now. Boring, very boring, yeah. Well, this is falling. Cool. What's a little bit interesting is how we create Bitcoin addresses, because there was a sort of also evolution how we do this on the Bitcoin network. Initially, we started to operate, we use public keys as addresses. Then later on, this is the correct slide. We started to do just hashes of the public keys. Then, as I mentioned, we found out multiple ways how we can, what kind of locking scripts we can have for, and conditions we can have for transactions, like multi-signature things and stuff like that. So we started to do hashing. We started to hash the scripts. And then 4 or 5 years ago, when there was this huge beef over Bitcoin and Bitcoin Cash, there was this thing called SegWit, which was introduced into Bitcoin protocol. Maybe some of you may remember. It was a super interesting fight, and people started to hate each other. If some of them were pro and some of them were against SegWit. But the result of this was actually that we created a new format for addresses, which started with BC1. The previous format started with number 3, always in the beginning of the Bitcoin addresses. And it's like, it saves the space in the blocks. It makes the transactions cheaper. But at the same time, this not this particular format of the addresses, but the SegWit upgrade also effectively increased the block size to some extent, a little bit. Cool, super boring as well. Bam, bam. Yeah, some links for people who want to a little bit play around with these things and read more about the Bitcoin script. So these are very cool resources for that. Digital signatures, probably we skip it. It's like a magic cryptography. No one understands that. We don't care. Yeah, bam, bam. Yeah, that's maybe important things to mention, that there is no such a thing as a balance in the Bitcoin network. So anytime you look in your Bitcoin wallet, it actually doesn't know its balance. The only thing it actually does is that it scans the whole blockchain, and if it's smart, it indexes into another database. But it scans the whole blockchain and checks for the UTXOs that were assigned to your address. And that's the only way it can find out that what kind of Bitcoins you have in your wallet. And that's the difference in Ethereum and other coins, that there you have actually this concept of state and of the account balance. So this, it just makes it a little bit tricky from the UX perspective. when you work with Bitcoin particularly. Bam, super. Now we're going to a little bit more interesting topic, hopefully. Lightning Network. Who has heard of it? More people, very cool. I will not get much into the concept, how it works. I just wanted to show some of the latest data. This is actually from this month. And Lightning Network was released around like exactly 4 years ago, I think, for the first time. And this is how it grew over time. So this particularly tells us something about the amount of payment channels that are on average on the network. I mean, they are being closed and open every day, multiple of them, but on average, we can see, especially this, 1.5 year kind of nice increase. As well, when we talk about the capacity, how many Bitcoins are locked on the Lightning Network, and that's a very important thing as well, because it tells us also about, how much, how functional is the network as well. Of course, it got decreased since we are in the dip, but the amount of Bitcoins in the network is growing constantly, basically, and now we are at the 5,000 Bitcoins. So that's it's not so much, but it's like it's nice as well. And of course, did anybody do any transaction on the Lightning Network? Few people. Did anybody do it this year? 1, 2. Cool. Yeah, so I think this year it got really better compared to the previous years. It was super tricky and super hard to play with the Lightning networks, but now we're getting slowly there, so it's like not such a pain in the ass, which is very nice. Can't see the headline. Shame. This is just a very brief overview of all kinds of innovations that are happening on the Bitcoin protocol. There are like a lot of them. I will not get into it. What was interesting for me was, for example, when the Microsoft decided to do their digital identity solution, they chose Bitcoin blockchain, but I haven't heard anything about it in the last year, so I'm not sure how the project is progressing. But there's a lot of things happening in general, like on the different aspects, like when it comes to mining, privacy, usability and performance, layer 2 things. There's a lot of things going on there as well. Side chains, which could be considered kind of layer 2 as well. And so if you are interested in that, you should definitely look up these projects because they make Bitcoin much more usable. Yeah, this slide should have been there before, never mind. Very basic comparison, transactions on the Bitcoin blockchain versus Lightning Network. So Lightning is cheaper, faster, less secure, high throughput, and ideal for micropayments. If we look at the data, the average transaction on the Lightning Network is around $50, and the median is around $5. So that gives you an idea what kind of transactions are happening there. And the cherry on top, something that I have no clue about, because it was super new, but I wanted to mention it today because I think it could be something that you could play around and learn about. It's so-called Tara protocol. It was released just 4 weeks ago. The first, when they open source the code and released the first daemon. It's something that should bring NFTs and stablecoins and some other smarter functionality on top of Bitcoin. And but it's also important to say that it's not the first such a protocol. In the past, we had kind of a bunch of them. Even if you look at the history of the crypto, if you read it here, there were kind of a few NFT projects on top of Bitcoin in 2015, 2016, but they didn't catch up, and everything basically moved later on to Ethereum and other chains, and now no one cares about NFTs and Bitcoin. But this could change it perhaps, because actually the company behind this is Vacuumlabs. They are one of the biggest contributors to the Lightning protocol as well. So this is kind of their project as well. And they are more business savvy compared to other teams in the space. We had something similar that was doing basically the same things but in another way on Bitcoin. It's called the RGB protocol. It's like 2-3 years old. So this is very new and improves the whole concept. And how it works, yeah. So it should, of course, also be accessible globally to anyone, privacy preserving, works for any kind of non-fungible assets. It should also improve the privacy when it comes to transfer of the assets. So very cool on the paper. We will see how it be in reality. And what is interesting that you of course. Similarly, with the Lightning Network, you always need to have some on-chain transactions where you refer these so-called taro assets when you open also the taro channels. And so it operates on top of the Lightning Network, but not every Lightning node will route these kind of transactions, and because they also need to operate another additional software, and they may not choose to do so. It's optional, and we will see how it really will work in reality. So we have blockchain here. We have these black lines, are payment channels on the Lightning Network, and then we have the green lines, which are some particular Taro network channels. It should definitely increase the functionality of the Bitcoin network, but there's still a long way to go. For the geeks here, this is how it works. So we mentioned these UTXOs, and how it works is that they have embedded in the UTXO something connected to this Taproot UTXO, which is this big protocol I mentioned that happened in the last year. And there is a whole lot cryptographic magic around it that I have no clue about. So I can just look smart because I have it on the slide, but that's about it. Good. Sources. I had some sources before. That's all from me. But if you are really into it, there is a really nice book called Mastering Bitcoin that is freely available out there. And chapters 2 and 6 particularly talk about the things that I was talking about, transactions, blogs, and things like that. It's super nicely written, and if you're interested, I definitely recommend to read it. And then there is this Constructed Attack, which is my book, where I talk and write about the history and evolution of cryptocurrencies in general. And I do mention a lot of things from the past, and not only from the Bitcoin protocol, but other protocols as well. And I have 2 books with me here, so if you want to buy it, you're welcome. I'll be happy. But it's completely available for free on this website. And and the particular chapter that talks about the Bitcoin protocol and its evolution is chapter 6. And the last information slides from these presentations are here, slides.com/Stancel/BTC. Thank you very much.